Hi, in section 7.2 we'll be looking at right triangle trigonometry. So right triangle is a triangle in which one angle is a right angle, and by definition a right angle is a 90-degree angle. The side opposite to the right angle is called the hypotenuse. So let's write that down. Hypotenuse. So as you can see, it's directly across from the 90-degree angle. The little square that indicates it's a 90-degree angle, which is 90 degrees, and the side that's opposite of that 90 degree is always going to be the hypotenuse. The other two sides are defined as the opposite side. So you have an acute angle T. Acute means that it's between 0 and 90. As you can see, this angle is acute. It's between 0 and 90 degrees. So relative to this angle, the side that's opposite would be this side right here, and the side that is adjacent would be the side down here. Okay, so that's the terminology that they use when referring to a right triangle. They'll say hypotenuse, which is the longest side of a triangle, and then you have two other sides, the opposite side and the adjacent side, relative to a specific acute angle. Okay, so there are 6 trig functions that we're going to learn. The first one is sine. Okay, so sine is a ratio of the opposite to the hypotenuse. Opposite to the hypotenuse. Okay, so it's going to be the ratio. If you're looking at this triangle up here, the sine of the angle T would be the opposite over the hypotenuse. So this side divided by this side, that's the ratio. For cosine, the ratio is going to be the adjacent side over the hypotenuse. So once again, relative to angle T, the cosine of angle T would be this side, adjacent over hypotenuse. And finally, the third one is tangent, and tangent is the ratio of the opposite over the adjacent side. So the opposite to the adjacent side. And there's a famous acronym that is useful when you're learning this for the first time. It's SOHCAHTOA. So SOHCAHTOA can be spelt this way. And so what that refers to is the ratio of the 3 trig functions. So sine is opposite over hypotenuse. That's the SO. Cosine is adjacent over hypotenuse. That's the CA. And then the TOA is the tangent, is the opposite over the adjacent side. Okay, so that's very useful, and they explain it down here. The 3 reciprocal functions are going to be cosecant, which is abbreviated as CSCT of the angle T, and that's the reciprocal of the sine function. All right, secant, which is abbreviated SEC, is a reciprocal of the cosine function. And finally, cotangent COT is a reciprocal of the tangent function. Okay, let's move down here. And here they explain SOHCAHTOA. So it's what we kind of talked about a little earlier. It refers to the ratios. So remember, sine is referred to as the opposite over the hypotenuse. Cosine is referred to as the adjacent over the hypotenuse. And tangent is opposite over adjacent. So remember that this acronym should help you remember that sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite over adjacent. And then you have the reciprocal functions that we just kind of defined earlier. Since cosecant is a reciprocal of sine, to get the cosecant function, all you have to do is take the reciprocal of the opposite over the hypotenuse, which would then become hypotenuse over opposite. You're just flipping the fraction. The reciprocal of secant, which is cosine, would be hypotenuse over adjacent. And cotangent is a reciprocal of tangent, so it would be adjacent over opposite. So you're just literally flipping the fraction. That's how you get the reciprocal functions. So oftentimes you'll just get these 3 here, the main 3 ones, sine, cosine, tangent. And then to get the other 3, you simply have to take the reciprocal of the ratios, and then that'll give you the cosecant, secant, and cotangent. Okay, let's move on to the next page. Okay, so now we're going to do an example. So they give us a right triangle with sides 3, 4, and 5, where 5 is the hypotenuse. Find cosine of alpha if the side adjacent to alpha is 3. So first let's draw a picture of a right triangle. Okay, here's our alpha. We know that the hypotenuse is 5. They tell us that. And they say that the adjacent, the side adjacent to alpha is 3. So that would be this one. That's adjacent. And then the side that's opposite of the angle alpha would have to be 4, since it's a 3, 4, 5 triangle. Okay, so they're asking for us to find cosine of alpha. So recall that SOHCAHTOA is this acronym. Since they're asking us to find cosine, that means we're going to go with this one. And then cosine of alpha is, we know, adjacent over hypotenuse. That's why this is useful, adjacent over hypotenuse. So remember that the adjacent side is 3 and the hypotenuse is 5. So our final answer will be 3/5. That's what the cosine of alpha is equal to. Okay, let's look at the next example below. Find the exact value of sine of t if the hypotenuse is 25 and the side opposite angle t is 7. Okay, so let's draw the picture once again. So, got a right triangle. We know that the hypotenuse is 25, the angle is t, and the side opposite of t is 7. This would be the side opposite. So now we actually have to find the sine of t. It's always useful to actually find the missing side. Sometimes it'll be useful. In this case, you don't really need it because sine is opposite over hypotenuse. But let's say they were asking for cosine, and that would be adjacent over hypotenuse. So we would need this missing side. So let me show you how to find it. There's a famous theorem. It's called the Pythagorean theorem. And let me write that out for you. Pythagorean theorem. Which says that if you have a right triangle, A, B, and C, then the theorem says that a squared plus b squared equals c squared. So that's what we're going to apply. Let's go ahead and call this A, and then we're going to apply the Pythagorean theorem. A squared plus b squared is equal to c squared. Notice that the hypotenuse always has to be c. All right, so this is going to be a squared plus 49 equals 625. If you subtract 49 to both sides, you're going to get a squared equals 576. Now we take the square root of both sides of the equation to get a by itself. And if you take the square root of 576, you're going to get plus or minus 24. But in this case, since we're talking about lengths of a triangle, that means that we are definitely going to go with the positive in this case. Okay, so it is 24. And now we can find the exact value of sine of t. So sine of t, if you recall, is so opposite over hypotenuse. In this case, the opposite side is 7 and the hypotenuse is 25. So our final answer will be 7 over 25 for that. Had they asked for cosine, it would have been 24 over 25. And had they asked for tangent, it would have been 7 over 24. Okay, let's move on. So there are two special triangles, right triangles. One is called the 30, 60, 90 triangle, all right? And the other is called the 45, 45, 90 triangle, okay? So what makes them special is that their sides are in the ratio of 1, square root of 3, 2 for 30, 60, 90 triangle. So in this box, in this empty space, you want to put in square root of 3. And for the 45, 45, 90 triangle, what makes that one special is that it's in the ratio, the sides are in the ratio of 1, 1, square root of 2. Okay, we can draw a picture of that. There's a picture here below. I'll just recreate it. Let's call this 60 degrees. We'll call this 30 degrees. So if hypotenuse is 2, then the short leg has to be 1, and then the other side would have to be square root of 3. All right, so that's the ratio in which the sides would be if it's a 30, 60, 90 triangle. And for the 45, 45 degree triangle, that would look something like this. 45, 45. If these were both sides 1 and 1, then the hypotenuse would have to be square root of 2. All right, let's see if we can solve or evaluate these problems here. It says use the side lengths to evaluate the following. Okay, so notice that pi over 3 is here. Pi over 3 is equivalent to 60 degrees. You can verify that if you'd like. Or we can just simply use this triangle. So since we're looking for sine, recall that sine is so that means it's opposite over hypotenuse. So the sine of pi over 3 is going to be the opposite side, which is this side, divided by the hypotenuse, which is this side. So it's square root of 3s over 2s. So let's write that out. Square root of 3s over 2s, where s can be any number. Okay, so, and as you can see, we can cancel out the s's. So the final answer is simply square root of 3 over 2. Okay, let's keep it moving. Let's go to the next page. To the previous page. The tangent of 45 degrees, well, 45 is pi over 4. You can verify that. If you do the tangent, remember that tangent is TOA, which means opposite over adjacent. So relative to this side, relative to this angle, opposite over adjacent would be S over S. Okay, or if you look at my picture, I don't use S square root of 2S, I just use 1 square root of 2. It would be 1 over 1. But let's use S's. The tangent of pi over 4, or 45 degrees, is going to be opposite over adjacent, which is S, 60, 90 triangle. So pi over 6 is 30 degrees. Since they're asking for secant, it's the reciprocal of cosine. So cosine is A adjacent over hypotenuse. So the reciprocal of adjacent over hypotenuse would be hypotenuse over adjacent. So we're looking at the secant of pi over 6. The adjacent side would be square root of 3 over s, and the hypotenuse is 2s. But we're doing the reciprocal, so instead of this over this, it's going to be the hypotenuse divided by square root of 3. So it's going to be 2s over square root of 3s. All right, now they're asking us to find the tangent of 45 degrees. So let's go back over s, which is just 1. All right, so it's just 1. All right, the last one of this type of problem is the secant of pi over 6. Pi over 6 is equivalent to 30 degrees. You can verify that if you do the conversion. Let's go back to the triangle. 2s over square root of 3s, and now we can cancel out the s's, and we end up with 2 over square root of 3. However, we do need to rationalize the denominator. Rationalize the denominator. That means that you're never supposed to have any irrational number in the denominator for some reason. It's just a rule in math. So to get rid of the irrational number in the denominator, what you do is you multiply top and bottom, the numerator and the denominator, by square root of 3 over 3. And that's going to give you 2 square root of 3 over square root of 9. And square root of 9 is simply 3. So that is the final answer. Okay. Okay, if we move on, they're going to tell us what cofunction identities are. So if you have two angles that are complementary, that means that their sum is 90 degrees. Okay, so 90 degrees, which is the same thing as pi over 2. Those are equivalent. 90 degrees is obviously in degrees. Pi over 2 is in radians. So here are the following identities, the cofunction identities. Sine of t is equal to cosine, which is pi over 2 minus t, or 90 degrees minus t. For all of these, they're all going to be the same. It's always going to be pi over 2 minus t, pi over 2 minus t. You just have to know that sine and cosine are cofunctions of one another, tangent and cotangent are cofunctions of one another, and secant and cosecant are cofunctions of one another. Okay, so this will come in handy when you get a problem, something like this. You can use this formula here and just call it sine of t, because cosine of pi over 2 minus t is equal to sine of t. So this is equal to sine over t. So we can simply write cosine of pi over 2 minus t is equal to sine of t. That's the cofunction identity. And they tell you what sine of t is equal to. It's equal to 5 over 12. So that is the final answer, 5 over 12. Okay, let's keep it moving. So now they're going to talk about angles of elevation and angles of depression. Okay, so let's see what they say. The angle formed by a horizontal line and the line of sight to an object above the horizontal is called the angle of elevation. So when you're looking up, it's going to be an angle of elevation. But if you're looking down, then it's going to be or below the line of sight, then it's going to be an angle of depression. All right, so for example, if your line of sight is here and you're looking down at an object down here, then this would be referred to as an angle of depression, because your line of sight is horizontal. No, I'm sorry, your line of sight is down to the ground, and your horizontal line is up here, so you're looking below the horizontal line, so that's the angle of depression. If your vantage point is down here and you're looking up, then that means this would be an angle of elevation, because you're looking up and the horizontal is down below. Okay, let's go ahead and go to the next page to do an example. So you have a 33-foot ladder that leans against a building so that the angle between the ground and the ladder is 80 degrees. How high does the ladder reach up to the side of the building? So let's draw a picture first. So here's our building. Okay, and then we have a ladder that's 33 feet long. So this is the hypotenuse is 33, because that's the length of the ladder. This is going to form a right triangle, as you can see. They tell you that the angle of elevation is going to be 80 degrees. It's the angle between the ground and the ladder. And they want us to find how high does the ladder reach up the side of the building. So in other words, they want us to find this length here, from here down to here. So I'm going to call it h. Okay, now we got to figure out which of the three trig functions makes the most sense to apply. So COTOA will be very helpful here. Relative to the angle 80, notice that we're looking for the opposite, and we know the hypotenuse. Opposite hypotenuse would mean that you want the first one, so, which is sine. So we're not going to apply these because it doesn't apply. What applies is the sine function. Sine of 80 degrees is equal to the opposite, which is h, over the hypotenuse, which is 33. Once again, the opposite is h, and the hypotenuse is 33. That's what the OH stands for, opposite over hypotenuse. And now we simply need to solve for h. So this is just an easy algebraic equation. To solve for h, you have to multiply both sides of the equation by 33 in order to get h isolated. So you get h equals 33 sine of 80 degrees. So it's really important to make sure that your calculator is in degree mode. So if you don't know how to do that, you should look up how to convert your calculator into degree mode. If you type this into your calculator, you should get approximately, if you round to one decimal place, h is equal to 32.5, and the units are feet. So that's how high the ladder reaches up against the building, along the building. Okay, for the last problem of this section, they give us they have a picture already there for us, and it says to find the height of a tree, a person walks to a point 30 feet from the base of the tree. So here's our 30 feet from the base of the tree. She measures an angle of 57. This is an angle of elevation because her line of sight is above the horizontal. All right. And they want us to find the height of the tree. So here's your right triangle. You can actually draw it if you want. You can just draw a perpendicular line here to the horizontal line, and there's your 90-degree angle. Since I'll call that h again for height of the tree. And now we got to figure out which of the three trig functions applies. So, ka, toa. In this case, relative to our angle, 57 degrees, we have we want to know what the opposite is, and we know the adjacent. So there's no hypotenuse. So you don't want this one, and you don't want this one, so we're going to use tangent, because tangent involves the opposite and the adjacent side. OA, opposite, adjacent. Okay, so let's write the equation. So it's going to be tangent of the angle 57 degrees is going to equal to the opposite, which is the h, and the adjacent, which is the 30. And same as above, to solve this equation, you have to multiply both sides of the equation by the denominator. And once again, make sure your calculator is in radian mode. So h is going to equal to, I'm sorry, degree mode, not radian mode. H is going to equal to 30 times the tangent of 57 degrees. And if you work this out on your, or type this into your calculator, you should get, and let's just round to one decimal place, you should get 46.2 feet. Okay, and that is it. That takes care of this section.